Good morning, students. Welcome to the next lab session. Today we're going to perform a differential amplifier experiment. This is a basic circuit of a differential amplifier. We have V1 input and we have V2 input, and basically going to take two outputs from the collector of both the transistor. So differential amplifier is one which is going to amplify the difference between V1 and V2 and take the output across this. So basically it is V0 will be, if you see it is be say V1 minus V2. So where the differential amplifier is being used, for example, let me tell you an analogy. For example, we have a tape with audio plus music, but I need only the music content of the particular tape. So what I'll be doing is, in one of the input, I'm going to give the audio, that is the voice of the singer, plus the music, and basically give V2 just the audio. So what happens is, ultimately, I'm going to get the output only music. Why? Because the audio gets cancelled. The other important application of differential amplifier is, for example, if a noise voltage is being affected at V1 and 100% the same noise voltage will be applied at V2 also. So what happens ultimately, the noise voltage at V1 gets cancelled with noise at V2. So a differential amplifier circuit is of course mainly used to remove or to amplify a particular part of a signal, and of course to remove any noise on the input. If you take an op amp uses this differential amplifier as a basic circuit. And students, as you know, the op amp, we can use it for n number of applications like adder, subtract, or differentiated integrator. And there are quite characteristics needed for an op amp. That is, for example, what we call as a CMRR, which is called a common mode rejection ratio, which should be very high. So let us see what this common mode rejection ratio is. For that, we should know what is called as common mode gain and differential mode gain. Common mode gain and differential mode gain, which we call it as AC and which we call it as AD. A common mode gain is one where we are going to give the same input V1 here also. So this, we are going to take a wire and short both V1 and V2. So the same input is being applied. Ideally, my output should be 0 since both the inputs are at same. But practically it's very difficult. So we're going to find out what output we are going to get for a common mode signal. So for that, what we're going to do, we're going to short V1 and we're going to short V1 and V2 and perform the same experiment like what we done for a common emitter amplifier. So we're going to fix V1 and for example, we're going to fix V1 say for 2 volt at say 1 kilohertz and vary the frequency and find out V0 and find out what is V0 by Vi or V1 and find the common mode gain of 20 log V0 by V1 or Vi. And the next set of experiment what you're going to do is I'm going to calculate the differential mode gain, which is I'm going to give V1, and since I need to use two function generator for giving V1 V2, what I'm going to do is V1 I'll be giving through the function generator and V2 I'm going to ground, so that I can vary V1 and now find out the gain. So similarly, you can again conduct for the various frequency, you can note on the output. Again, you can calculate V0 by V1 or what Vi and find what is AD, which is 20 log V0 by V1. So ultimately, I get AD by AC to calculate what is called the CMRR. Since my common mode gain should be very low and CMRR will be very So that is the important characteristics of an differential amplifier, to have a high CMRR, so that it neglects the common mode signal and amplifies the differential mode signal. So the potential divider values and that is basically the biasing values can be calculated by using the same design what we saw in the first experiment, or you can also use the same values what you have done for the common emitter amplifier. It's not a harm or no issues. This is a different design, and this is the experimental setup. So first you're going to give V1 for common mode, short the wire V1 and V2. For differential mode, make V2 grounded and perform the experiment and calculate the value of CMRR. Thank you.